more video or more identities and more formulas. We're not going to get beat up anymore with the identities. Okay, so you can start enjoying Trig class again, and the grades tend to be in this class a cosine curve. Start out really high, they start trickling off in the middle. They bottom out around trig identities. Then they start accelerating upwards again. So it's sort of like a cosine curve with respect to grades. Grades tend to pick up a little bit more this last couple quizzes that we have here. Today we're going to deal with arc trig functions, or inverse trig functions. When we are dealing with trig functions, if I have y is equal to the inverse sine of 1/2. We've done this problem before. The problem we've run into with dealing with the problem in this fashion and how it's written is this -1 exponent. Yes, it means an inverse function, but it also has a double meaning in the trig or in the algebraic world. If we have something to the -1 exponent, if we have x to the -1st power, this means 1 over x. So if I take this as a context as this is an exponent of -1, I can also rewrite this as 1 over the cosecant of 1/2, which is incorrect. So there's a dual meaning to this -1 exponent. So when we have this dual meaning, what has been created is a different way of writing the inverse trig function. And that is the utilization of what is called an arc sine of 1/2. When I'm dealing with the inverse sine, this can also be written as the arc sine of 1/2. The arc sine of 1/2. Or when you see the arc trig function there, that means to do the inverse trig function. So when I see the arc cosine of -1/2, the arc cosine of -1/2, this means the inverse cosine of -1/2. Now, if I take a look at my variable is just a letter, which tells us that we have to deal with these in radians. When we have a letter there, we need to be dealing with things in radians. Well, if I change my calculator to the inverse cosine of -1/2 in a radian mode and came down to a value, I'm just going to get an irrational decimal. And I don't want a decimal. I want to have an exact value here. When I see this is a capital letter, this tells me to calculate a principal value. So this is where, once again, we start to bend the rules a little bit. I keep my calculator in a degree mode. I do my inverse cosine of -1/2 in the degree mode. And come down to a degree value, which is what? 120? This comes down to 120 degrees. Because I'm dealing with a principal value, I'm dealing with a capital letter. This is a calculator value. We get a value of 120 degrees. And 120 degrees we can now convert back to radians in terms of pi. pi was equal to 180 degrees. Pi over 6 was 30 degrees. Pi over 4 was 45 degrees. Pi over 3 was 60 degrees. These were the key values that we utilized. And we can ask ourselves, what number here can I multiply by a value to get 120 degrees? Now I want to pick my biggest value. 60, 45, 30, 180. Which one of those numbers can I multiply by a number to get 120? Mason, which one? 60. 60. What do we multiply 60 by? 2. So we multiply this by 2. So what I do to one side to keep it in balance, I can do to the other. So I have 2 times pi over 3, or the value of 2 pi over 3. I want to find the arc cosecant of 2, which means I'm looking for the inverse cosecant of the value of 2. The problem we run into, we don't have an inverse cosecant button on our calculator. But we can deal with the reciprocal function. What's the reciprocal function for cosecant, Bennett? Sine. So we can rewrite this as the reciprocal function. So we can do the inverse sine. But what do you think we have to take the inverse sine of? We reciprocated our trig function. What should we take the inverse sine of? What would be a guess that we could do? We reciprocated the trig function to go from cosecant to sine. 1/2. We reciprocate your value. So we could take the inverse sine of 1/2. We reciprocate the trig function, we reciprocate the value. So we have the inverse sine of 1/2. Find a degree measure, then convert it into a radian mode in terms of pi. Grace, what do you come down to? 30 degrees, which is what in terms of pi? Pi over 6. Good, do the inverse tangent of 45, or I'm sorry, square root of 3. What would be the inverse tangent or arctangent of square root of 3? This is so much nicer. I'm just clickety-clacking through my calculator. Oh, this is so nice. I don't have to draw a right triangle. I don't have to use my good old buddy Pythagoras. I don't have to take the sine of A times the cosine of B plus the cosine of A times the sine of B. So much nicer. Molly, what do you come down to? Hmm? 6 degrees? Yes, no, maybe so. And in terms of pi, in radian form, in terms of top pi, what would that be, Courtney? Pi over 3. Pi over 3. Now, your calculator, or if we deal with inverse trig functions, and I take a look at the principal values, no matter what, if I take the inverse sine of any decimal, positive or negative, I'm going to be in between negative 90 and 90 degrees. Your calculator is set up that way also. If I take the inverse sine of a negative value, I'm going to be between negative 90 and 0. Your calculator will do that for you. If I take the inverse sine of a positive value, it's going to be between 0 and 90 degrees. Your calculator will do it for you. If I deal with the arc cosine, which is the inverse cosine, my angle measures are going to be between 0 and 180 degrees. Your calculator will do that for you. It is programmed, it is set up to give you the principal value, or 0 to pi. Tangent, negative 90 to 90, or negative pi over 2 to pi over 2. Your calculator is set up. Once again, if I take the inverse tangent of a negative value, I'm going to get a negative anywhere between 0 and 90 degrees. If I take a look at the arc sine and then the arc cosecant, the reciprocal of it, they will fall right in line. These values will be in between negative 90 and 90. For arc secant and arc cosine, they'll follow the same line, 0 to 180 degrees. Your calculator is set up that way. Once again, the only one that's going to be different when I'm talking about an arc tangent, I'm going to get a value between negative 90 and 90 degrees, no matter what. When we do the arc cotangent, the principal value for the arc cotangent is between 0 and 180 degrees. If I have the arc cotangent or inverse cotangent of negative 1, by utilizing what we just did up top, this is going to be the inverse tangent of 1 over negative 1. I just reciprocate that. I put a 1 over. So I'm taking the inverse tangent of negative 1. Well, if I take the inverse tangent of negative 1, I clickety-clack that through the calculator. Inverse tangent of negative 1. Isaac, what do you get? Negative 45 degrees. Well, originally, this was our question. And my solution has to be between 0 and 180 degrees. Problem we have is negative 45 is not there. So how do we solve this problem that we run into? Well, as I've talked about before, this is your negative 45 degrees. This is where your tangent and cotangent is negative. But where else that is negative is up here in quadrant number 2. So to go up into quadrant number 2, looking what we have, this is 45 degrees, this is a line, this is a line. What we have here is called vertical angles. If you remember back to your fond memories of geometry, we have vertical angles. And by definition, all vertical angles, or a theorem that's out there, all vertical angles are congruent. And by definition of congruency, congruent angles will have equal measures. So if this angle is 45 degrees here, this angle up here also has to be 45 degrees. Well, to go from here to here, we can add 180 degrees. So over here, we add 180 degrees to give us 135 degrees. (45 times 3 is 135. So we have pi over 4 times 3. So we have 3 pi over 4. The only time you have to do this, only time, is when I'm dealing with the inverse cotangent of a negative. when we take the inverse cotangent of our negative, we get our solution, we have to add 180 to it. If I'm taking the inverse tangent of a negative, I don't have to worry about it. But at the inverse cotangent, my problem initially starts out the inverse cotangent of a negative. Then I must worry. Take a look at some problems. Your first set of homework problems for today is just going to be doing what we just did up front on the first page. The second set of problems will be what we're dealing with here. I want to find the tangent of the arc sine of 4/5. I want to find the tangent of the angle whose sine is 4/5. Whenever I deal with an arc tangent or arc sine or arc cosine or an inverse, whatever, you're going to come down to an angle. Well, what I want you to do is I want you to click-clack through your calculator the inverse sine of 4/5 and get a degree measure. For New Hampshire, what is that degree measure? Okay, 53 degrees. Well, what all I'm worried about and concerned about is which quadrant should I put my triangle? This tells me 53.1 degrees, which puts me in quadrant number 1. And the sine of this angle has to be 4/5. So using my definition of sine, sine is opposite over hypotenuse. We have 4/5, opposite over hypotenuse. Using our Pythagorean triples, what's the third side here? Hayden's? 3. So if I take a look at this triangle, I want to find the tangent in this triangle. The tangent of my triangle that I have there is what, Mia?
4/3.
4/3. 4/3. Find the angle whose sine is negative 5/13. Draw your angle in that quadrant. Put the sine of that angle being negative 5/13. Find the third side, and then find the cosine of it. Inverse sine negative 5/13. Which quadrant are you in, Lexi?
4.
Quadrant number 4. So I draw my triangle in quadrant number 4. The sine of that angle is negative 5/13. Third side of the triangle. What's our third side of the triangle? I got a 5, I got a 12. Emma, what's the third side? Alright, sorry, 5 and a 13. What's the third side? 12. There we go. So now I'm going to look at my cosine of this triangle. So if I take a look at the cosine of that triangle, Carter, what do we have? 12/13. 12/13. whenever you do an inverse trig function of a positive, and if you want to remember this, this is fine. If you don't, you can still clickety-clack it through. When you do the inverse trig function of any positive number, you're going to be in quadrant number 1. You'll be in quadrant number 1. Any positive value, you do the inverse trig function, you'll be in quadrant 1. So I have the arc cosine of 2/3. So it puts me in quadrant number 1. The cosine is 2/3. I can find my third side if I want to, but what I need to find is the cosine of this. I could find this to be square root of 5. 2 squared plus y squared is equal to 3 squared. So I can subtract 4 over from 9 and get square root of 5. But I'm trying to find the cosine of this. Well, if I find the cosine of that, Sean, what do we get? 2/3. It undoes each other. We just have to watch ourselves to make sure we're principal values. You want to work yourself outside or inside out. We have the arc cosine of pi over 6. I'm sorry, the arc cosine of the cosine of pi over 6. So I work myself inside. I have the angle pi over 6. If I have pi over 6, what is the degree measure for pi over 6, Riley?
30.
I'm sorry, what? What did you say?
30.
30. So it's 30 degrees. So I'm going to draw my 30-degree angle. The 1 to 2 to the square root of 3 continues to come back to us. 1's across from the 30, 2 in the hypotenuse, square root of 3 here. So I find the cosine of pi over 6. The cosine of pi over 6. Well, if I look at my triangle, the cosine of pi over 6. What's our cosine of pi over 6, Megan? What's the cosine of 30 degrees? So I can take the arc cosine of my calculator, square root of 3 over 2. And we should come back to 30 degrees, which is pi over 6. Once again, they should undo each other. I'm going to skip this one because it gives an empty step, but I'm going to go down to here. This is where you have to start watching yourself. Sine of 2 pi over 3. 2 pi over 3 is what degree measure? Take a look at your pi over 3 and multiply by 2. What's pi over 3? Multiply by 2. Isaac, what do you get? 120. So we get 120 degrees here. So in my picture, we have 120 degrees. Our reference angle, what's our reference angle going to be, Brianna? Genevieve? 60. So I need to get my values down there across from, this is 30 here, across from my 30 is a 1, hypotenuse 2, square root of 3. Check for any negatives. So I have a negative with the 1. So I have to take the arc sine of the sine of 2 pi over 3. So looking at our triangle here. I want to find the sine of my 120 degrees, which is the sine of my reference angle. Tori, what's our sine of our angle here? Square root of 3 over 2, opposite of our hypotenuse. So now in my calculator, I can clickety-clack through. Now watch your calculator, make sure you close parentheses out here, or pull yourself out of the radical, which I inevitably would always forget to do. So we have the inverse sine of square root of 3, close your parenthesis out, or pull yourself out of the radical, divide by 2, and then end your parenthesis out. What is the degree measure you come to? Okay, what do you get? 60 degrees. 60 degrees, which in terms of pi is pi over 3. So what we have here is the arc sine of the sine of 2 pi over 3. Does not come back to 2 pi over 3 or 120 degrees. The reason why is, once again, we're talking about the principal value. The principal value. If I look at my sine on the front side, the inverse sine has to be anywhere between negative 90 and 90 degrees. Well, what I'm dealing with is 120 degrees. 120 degrees is not between those two values. Take a look at the last one. The arc cotangent of the tangent of negative pi over 3. Negative pi over 3. What's our degree measure? Negative pi over 3. Mason, what's our degree measure? Negative 60. So I'm going to draw my angle, my negative 60 degree angle. Puts us in quadrant number 4. So we have 30 here, we have 1 across from a 30, 2 and a hypotenuse, square root of 3 across from a 60. Since we go downwards, we have a negative value. So if I look at my cotangent, my tangent of negative 60 degrees, Bennett, what is it? What's my tangent down here? Negative square root of 3 over 1. So I'm taking in arc cotangent of that. Well, I don't have an arc cotangent button. So this is where I have to reciprocate and deal with my arc tangent. But if I reciprocate my trig function, I have to reciprocate this. So if I do my inverse tangent of 1 divided by negative square root of 3. What is our degree measure that we come up with, Riley?
Negative 30.
Negative 30 degrees. But the problem we run into with the negative 30 degrees is that we took the arc cotangent of a negative quantity. The only time that you have to watch out is when you have to deal with the arc tangent, cotangent of a negative. Because when you do that, what do we have to add to the negative 30 then? What do we add? 180. So you add your 180 to get you 150 degrees. Pi over 6 is 30. Which is 5 pi over 6. Once again, how I always deal with this, I look at pi, I just know my basics. Pi over 6, 30 degrees. What do I have to do to 30 to get to 150? I multiply by 5. So this will be 5 pi over 6. This will be the second part of your homework for tonight. Okay, you have on page 201, 202, 3 to 48 multiples of 3. The first half of them are just dealing with these right here. And some of them will be inverse trig functions, and some of them will be arc trig functions. The first half will be these. The second half will be these values over here. So there's a lot of clicky-clack, and make sure you keep it in a degree mode, keep yourself in a degree mode, and then convert things to radians then when you're done in terms of pi. Tomorrow we'll come in, we'll start dealing with law of sines and cosines. Once again, this is where grades tend to accelerate, and we start doing a little bit better. If we need the grades, these are grades that you should be able to pick up. What should you have? QED has done.